This is a second set of questions on Group 7. They are all multiple choice past paper questions from AQA A-Level Chemistry. Pause on the question, try to answer it, and then review. And that way you get to know what you are able to answer and what you might need to go back and look at in a little bit more depth. So let's start with question 1. And we're dealing here with which statement is not correct about the addition of chlorine to water. So always look out for that, because it can be very easy to go through, find the first correct one, having not read it properly, and miss that mark. Well, if we begin with Cl2 with H2O, this is the reaction that we would expect to see. It makes HCl and it makes HOCl. This is an example of disproportionation because the chlorine is being both oxidized and reduced in the same reaction. So that means that the answer is A, because we're not making an alkaline solution, we are most definitely making an acidic solution. Now, you might want to go through and review each of the others so that you can be confident that they are the wrong answers. But I'm going to move on at this point to next question. And we're being asked here for the best reducing agent in Group 7. And it's important to remember that reducing agents are halide ions. Halide ions can be oxidized to halogens. And that's what makes them reducing agents. So we can immediately disregard A and C. Beyond that, we have to remember that the reducing ability increases as you go down the group. Now, if you think about it, of course, the iodide ion is the most easily oxidized and therefore the best reducing agent. Its outer electron is furthest from the nucleus, so it's less attracted, and it's subject to more shielding. Next question. And some good, straightforward, practical recall here. We're looking at the silver halide precipitate with acidified silver nitrate. And we need to remember what colour precipitate we'll get, whether we'll get a precipitate at all. But we also need to be able to think about the rates of them as well. To do it, we have to break the carbon-halogen bond. So actually, what we're going to consider here is which of these will be the weakest carbon-halogen bond. Is it going to be a C to an F, to a Br, to a Cl, or to an I? Because that will be broken more rapidly, which means we will make the precipitate more rapidly. And the Ci bond is the weakest. It relates to an idea that we've just discussed. The iodide ion is the largest. So in terms of the attraction of the electrons to its nucleus is going to be weaker, and we'd expect the CF to be the strongest carbon-halogen bond. Next question. So the boiling point of halogens increases down Group 7, and we need to think about why. Well, electronegativity increases. We can disregard straight away because electronegativity will decrease down Group 7. We know that fluorine is the most electronegative element. We can also get rid of B. The bond polarities are, they're all van der Waals forces. There isn't a permanent dipole because there's no difference in electronegativity if I have an F2 or a Cl2 or a Br2 or an I2 bond. It's certainly not about the covalent bond strength. Actually, as we established on the last question, the covalent bond strength decreases as you go down the group. But even so, it wouldn't matter to boiling point, because when you boil a halogen, you're overcoming the intermolecular forces. And the bigger the molecule and the larger its surface area, the stronger the van der Waals forces will be, and therefore more energy needed to overcome them. So the higher the boiling point. Next question. So here we have an aqueous solution of a sodium salt giving no precipitate when treated with silver nitrate solution or barium chloride solution. And we've got to combine some different ideas here. First of all, I'm going to take Na2CO4 off the table because I know that I'm going to make barium sulfate. And we've learnt about the trend in solubility of group 2 sulfates. Barium sulfate is insoluble. It's what's used in the barium meal in hospitals. If I take a look at NaI, I'm going to make AgI, which is a yellow precipitate. And NaBr, we make a cream precipitate. Now you may also remember that AgCl is a white precipitate. NaF, we don't get a precipitate at all. Next question. So 4 different facts, which of them is true? Well, chloride ions cannot reduce sulfuric acid, so we are not going to see it get oxidized itself, so A cannot be correct. I'm going to add a little bit of information to deal with some of the rest of this. It's a table that you will be familiar with from GCSE as well as A-level, and if I react these combinations, chlorine with bromide ions, chlorine with iodide ions, etc., I will get positive reactions where I've given ticks and negative reactions where I've given crosses. Now I can carry that over to see that D would be a cross. So we're not going to get a reaction, so the answer cannot be D. Similarly, the answer cannot be C, because that reaction does not take place. It's all about the relative oxidizing ability of the halogens. Now that takes us to B. Sodium chloride produces chlorine when treated with bromine, and we can see that that one does take place. Next question. So, an aqueous solution of a white solid gives a yellow precipitate with aqueous silver nitrate. Yellow should immediately take us to I, iodide. So we're down to AgI or NaI. What's important then is to consider the formula of the white solid. Now, if we know that the silver halide is what gives the white, the cream, or the yellow precipitate for chloride, bromide and iodide respectively, then we're starting with the NaI. So the correct answer is D. Next question. So in this case, what will you see when a solution of silver nitrate is added to a solution containing bromide ions? Again, if you remember the colours of the precipitates, that's all you need. But we've got an extra bit here as well. Concentrated aqueous ammonia will also have an impact. So first of all, I can take away white precipitate because ultimately it would be chloride. And yellow precipitate we can take away because that would be iodide. So cream precipitate is enough to tell us the answer is C. But we also need to remember that chloride or silver chloride would be soluble in aqueous ammonia. Bromide is soluble in concentrated ammonia, and iodide is continuing to be insoluble even in concentrated ammonia. Correct answer is C. Next question. So we have got what is not a correct trend. Well, the electronegativity of atoms do decrease, and I've said this previously. We know fluorine is the most electronegative element, so we know the trend will be that it decreases down the group. The boiling point of the element does increase. Again, we've spoken about this already. It's a bigger molecule, it has a bigger surface area, so it has stronger van der Waals forces, and therefore its boiling point will increase as you go down the group. The first ionization energy does decrease because the outer electron is further from the nucleus, it's less attracted to the nucleus, and it's subject to more shielding. So it would be lost more easily. The oxidizing power of the element decreases Fluorine is the best oxidizing agent, and then chlorine, bromine, iodine. Again, we've already touched on that through this particular video. Next question. So which of these is true? Well, let's start off by considering that concentrated sulfuric acid will not liberate chlorine because chloride ions are not strong enough reducing agents to reduce sulfuric acid. So it can't happen. I'm going to put a table together here. We've already seen this once before, but let's go through. We've talked about the test, but here, let's look at the specific details. I will get a white, a cream, or a yellow precipitate for chloride, bromide, and iodide, respectively. If I add dilute ammonia, the precipitate will redissolve with chloride, but not with bromide or iodide. I don't need to do that to chloride ions with conc ammonia, but if I do it to bromide, the precipitate will then redissolve. Iodide, there'll be no visible change. Now I can also put together the displacement reaction table that we've already discussed as well. And if I put that information in, what we can see is that silver iodide, soluble in aqueous ammonia, absolutely not, because the yellow precipitate remains. If I take a look at bromine liberating iodine from sodium iodide, I can see that that does actually work. Bromine with iodide would cause a displacement reaction and I would get iodine. So the correct answer is A. Next question. And we're back to this idea of testing for halide ions. So white salt dissolves in water to give a solution with a cream coloured precipitate, and it is insoluble in dilute aqueous ammonia, but it is soluble in conc aqueous ammonia. So I'm going to take away the I minus because that would be a yellow precipitate, and we're down to AgBr and NaBr. And from there, because we're asked about the original white salt, we remember that we make the silver halide. That's what gives us the white, cream or yellow precipitate. So the correct answer is D, NaBr.